Let's continue to evaluate limits analytically, but this one doesn't factor. If you were to plug in a 0 for x, you would realize that you have 0 over 0, so we're in that situation again. And there's a neat little trick you can do when there are square roots. They don't always work this way, but this one is configured to where it does, and it's going to work out very neatly later as we demonstrate this with another type of problem. So we're going to multiply by something that is not obvious, that may not go through your head, but once you learn this little trick, it'll be like, oh, well, that's kind of cool, so we can do that. So we're going to multiply by everything in the numerator, only we're going to change the sign in between the two square roots. It's called the conjugate. And you'll see where this is going in a minute. So the square root of x plus 7 plus the square root of 7. And then, well, basically, I can't just change the problem, right? I can't just say, well, I'm going to just pretend like this says something else. I can change its appearance, but not its value. So I need to multiply by, well, 1. Like you multiply by 1, it changes nothing, right? It changes its appearance, but not its value. So we just multiplied by something over itself, which is 1. So there we go. Let's multiply. As we do that, the next step will look like this. We'll bring it down. Now we have not evaluated the limit yet, and I did not need to write lim here. Okay, we're multiplying the original expression by something and then continuing to try to figure out what the limit is. So we don't need lim here. That just no. Okay, the denominator is complicated if we distribute, but let's not. It's basically x times all this. So we're just going to write x times all this. There we go. And the numerator is something that I am not going to write consistently every time, but I will this time, because I want to demonstrate what conjugates do. If I wanted to multiply this numerator, I'd basically have this binomial times this binomial, right? And then I would say, well, the square root of x plus 7 times the square root of x plus 7 would give me the square root of x plus 7 squared. You can see where this is going. That square root's going to lift off and cancel with the squared. Then I would have, don't write this. I mean, you can if you want to, but in just a minute, once this cleans up, you're going to say, whoa, that was super fast. So square root of x plus 7 times the square root of 7, that gives me the square root of 7 times the square root of x plus 7. We could put them under the same radical if we wanted to. And then we'd multiply these, basically foiling, right? And then minus square root of 7 times square root of x plus 7. And then minus the square root of 49. Okay, so here's where this is going. And if you want to start writing at this point, you may, once I clear up a couple things. This positive square root of 7x plus 7, the negative square root of 7 square root of x plus 7, this cancels. They're the same. That's the point of a conjugate. Okay, so here's the deal. A conjugate is, you don't have to write this down, but this is a binomial that have, the binomials that have opposite signs in the middle. And if you were to multiply them out, you would end up basically with the difference of two squares. So you'd have a squared, negative AB and positive AB, well, those would cancel, and then minus B squared. And so the point of a conjugate is to get the outer and inner to cancel, which just happened, which means the next step of this problem, and this is where you can start writing again if you like, the limit as x approaches 0. Nothing special in the denominator yet, but the numerator, outer and inner canceled, and we had x plus 7. And then this was minus the square root of 49, so that was minus 7. And you can see where this is going, right? So the plus 7 and the minus 7, they're going to cancel each other out. And so we're going to be left with this in the denominator. Nothing special there yet. But you can see that this plus 7, minus 7, they're gone. And so the next step is going to look like this. Again, feel free to skip this step if you wanted to, because when you do, those are always going to cancel. There you go. You can jump straight to there if you like. Still haven't evaluated the limit. As x approaches 0 of x over x. You see that's about to cancel out and divide out, right? Me too. Okay. And we'll take the red pen and we'll say that this x cancels with this x, and it leaves 1 in both places. But we'll put it in the numerator for sure. So we have the limit as x approaches 0 of 1 over the square root of x plus 7 plus the square root of 7. I can now plug a 0 in for x. And so I have 0 plus 7, that's 7. So I have 1 over the square root of 7 plus the square root of 7. And well, square root of 7 plus the square root of 7 is not the square root of 14. It is 2 times the square root of 7. So I have 1 over 2 square root of 7. There we go. There's the first one like this. The second one like this is, well, another one that's really the same idea. So I actually recommend that you just try it on your own. You can mute the video and try it on your own. But I am going to explain it if you do need to hear an explanation. So give me a second to erase this. I'm going to write number 5 on the board, and you can try it on your own. I'm kidding. I didn't think I'd muted it. Okay, we're going to multiply by the conjugate. You see a square root often, not always, but often. It's a good strategy to try. So we're going to multiply by the conjugate of the numerator over itself, and that means that we are going to have times, okay. The numerator does have a subtraction in between the two terms, and we're going to put a plus instead. So we're going to put addition. So we'll have x plus 3 and then plus 2, and then we'll do the same thing in the denominator. That way we are basically multiplying by 1. We are changing the appearance but not the value. Okay, next step. Next step. Have not yet evaluated the limit. Oh, by the way, plugging in 1 from the beginning wouldn't have worked. Always a good idea to try that first, but I knew it wasn't going to work. Okay, denominator. If you wanted to FOIL the denominator, you could, but let's not. That's why I'm making this face like, oh, don't FOIL that denominator. Trust me. Just trust me. If you did, you'd have to factor it out again anyway. Not worth the trouble. Just leave it like that. Numerator, however, is square root of x plus 3 times square root of x plus 3, which is x plus 3. This would be positive 2 square root, and then this would be minus 2 square root. They would cancel. That's the whole point. And then minus 4. Okay, I see it, you see it, we both see it. Let's scream. Ah! I was thinking like I scream, you scream, we all scream for math. Anyway, x approaches 1. The numerator is x minus 1, basically. You can just go ahead and simplify that if you wanted to. And there you have an x minus 1. You know what's about to happen here, right? I sure hope you do. Really hope you do. X plus 3 and then plus 2. Handwriting's getting sloppy now, folks. Okay, we're going to cancel out the x minus 1. So cancel, cancel. There we go. And that leaves us with the limit as x approaches 1 of 1 over square root of x plus 3 and then plus 2. And now it is totally okay to plug a 1 in. So let's do. When I plug a 1 in, I'd have, well, 1 plus 3, so 4. The square root of 4 is 2. This becomes a 2. That becomes a 2. And that gives me 1/4. There you go.